In electrical engineering, the concept of leading phase difference refers to the situation when one voltage waveform leads another voltage waveform in time. Specifically, if voltage waveform VB leads voltage waveform VA by an angle phi, in radians, then we say that VB has a leading phase difference with respect to VA. A phasor diagram is a graphical representation of the amplitude and phase relationships between two or more sinusoidal signals. In the case of voltage waveforms VA and VB, we can represent their amplitudes and phases using phasors. A phasor is a vector that represents a sinusoidal quantity, where the length of the vector represents the amplitude and the angle of the vector represents the phase. To draw a phasor diagram for VA and VB, we first represent VA as a phasor vector pointing in the positive x direction. Then, we represent VB as a phasor vector pointing in the direction that is phi degrees ahead of VA in the counterclockwise direction, since VB is leading VA. The length of the phasor vectors represents the amplitudes of VA and VB, respectively. The resulting phasor diagram will show the relative magnitudes and phases of VA and VB. Specifically, the angle between the two phasor vectors will be phi, which represents the leading phase difference between VB and Virginia. If VB has a higher amplitude than VA, then its phasor vector will be longer than the phasor vector for VA. Overall, the concept of leading phase difference and phasor diagrams are important tools in analyzing and understanding the behavior of sinusoidal signals in electrical systems.